Good morning, students. I hope that you all have had a great week so far. I know y'all are super excited because spring break is coming up very soon. I know y'all are just ready for a break from math, right? I know I am, at least for a week. But in order for us to get to that break, we've got to finish our homework assignment first. So if y'all will, go ahead and get your homework assignments out, and we're going to start with question 1 from the assignment. Now, question 1 asks us, how many mouthfuls are in a gill, a cup, and a pint? Now, this is the information that we're given with the problem, and this information tells us how much of one measurement is in another measurement. So it's kind of like a doubling system like we're going to see here in a second. So in order to start this problem, let's just start with what we have. 1 jigger equals 2 mouthfuls. Now, to figure out how many mouthfuls are in 2 jiggers, we're going to just multiply this number by 2. We're going to double it. So 2 times 2 gives us 4, and that means that 4 mouthfuls is equal to 2 jiggers. And this is equivalent to 1 jack. And we're going to repeat the same process. In order to figure out how many mouthfuls are in 2 jacks, we're going to double this number again. So 4 times 2 equals 8. So that means that 8 mouthfuls are in 2 jacks, and this is equivalent to 1 gill. So we just found our first answer. 8 mouthfuls are in 1 gill. Now we're going to keep continuing this process, and now we've got 2 gills equals 16 mouthfuls because we multiplied 8 by 2 to get 16. We doubled it, and this gives us our answer for a cup. So 16 mouthfuls are in 1 cup. And now we're going to double 16 again. So 16 times 2 equals 32. And that means that there are 32 mouthfuls and 2 cups, which is also equivalent to 1 pint. So that's our final answer. 32 mouthfuls is equal to 1 pint. Now moving on to question 2. This question asks us to find the area and the perimeter of each triangle that we're going to look at in this problem. So in order to do that, we've got to know the area of a triangle formula, which is area equals 1/2 times base times height. And we're also going to need to know the perimeter formula, which is perimeter equals a plus b plus c. And these right here are just the side lengths, the outside of the triangle. So let's take a look at our first triangle. In order to solve for the area, we're going to do 1/2 times our base, which is 82.3, times our height, which is 41.0. And when we do that, we get 1,687.15 meters squared. Now, in order to find the perimeter, we're just going to add up all 3 sides. So 82.3 plus 48.0 plus 69.0 equals 199.3 meters. Now, we don't add this number because that number is inside of the triangle, and we are only looking for the numbers on the outside. So in case you were wondering why we didn't add that one, that's why. And that same rule will follow for the next 2 triangles. And this is our second one. Now, in order to find the area for this triangle, we're going to follow the same steps. We're going to do 1/2 times 37, because that's our base, and our height is 88.8. And when we multiply that, we get 1,642.8 inches squared. And we're going to find the perimeter next, which is just adding 37.0 plus 88.8 plus 96.2, and that gives us 222 inches. Now our third triangle looks a little different. It looks like this. Don't be afraid, it's the same exact concept. So we're going to find the area for this now. In order to do that, we're going to take our base, which is 6.2 centimeters, and our height is 2.6 centimeters. this 3.1, this is actually the length of that side. It's not the height. So just make sure that you know the difference between height and length, because those are two different things. So once we multiply this, we get 8.06 centimeters squared. Now for perimeter, we're going to measure the lengths of each side and we're going to add them together. So we've got 3.1. Now, like we said, this is a length, so that means we're going to use it for the perimeter instead of this, which is the height. So 3.1 plus 8.5 plus 6.2 equals 17.8 centimeters. So now we're finished with question 2, and we'll move on to question 3. Now this question, we've got this figure, and it wants to know which one is larger, the area of the region between the circles or the area inside the small circle. So the area of the region between the circles is the area of the larger circle, which is this one, minus the area of the smaller circle. So in order to figure that out, we need to start by finding the area of the smaller circle. Now the area of any circle is pi r squared. Now you might be wondering what the r is, which is radius, and we've already learned that radius is half of the diameter. Now notice that the square's length is 10 units, and that's also the diameter of the circle. So all we have to do is take half of 10, so 10 divided by 2, and that equals 5. So that means that our radius is equal to 5 units, and we're going to just plug in a 5 where that r is. So this is our equation now. So the area of the small circle is equal to pi, in parentheses, 5 squared, and that equals 25 pi units squared. Next, we've got to find the area of the large circle. And in order to do that, we've got to figure out the radius for this. Now, to find out the radius, we're going to do the Pythagorean theorem, which is a squared plus b squared equals c squared. And we know that our radius is 5, so we're going to just square that, and we're going to do 5 squared plus 5 squared equals r squared, so we can find the radius of the large circle. And that gives us 50. So 50 is equal to r squared. Now we're going to just plug in the 50 in place of the r squared into our circle formula, and we're going to get pi times 50, which equals 50 pi units squared. Now all we have to do, since we found the area of both the small and the large circle, is subtract the 2. So 50 pi, which is the area of the large circle, minus 25 pi, which is the area of the small circle, equals 25 pi units squared. So this question, it's asking which area is larger, but it actually is showing us that it's the same amount of area taken up. So none of them are larger, none of them are smaller. It's exactly the same. So that's it for question 3. Now for question 4, it says, the cylinder and cone in the figure both have a height of 2r. Show that the ratio of the volumes of the cone to the sphere to the cylinder is 1 to 2 to 3. So basically what this means is we're going to prove that this figure right here has a ratio of 1 to 2 to 3. Now in order to do that, we've got to find the area of the cone, the sphere, and the cylinder. So let's just go ahead and get started with finding the volume of a cone. Now this is the formula for a volume for a cone. So V equals 1/3 base times height. Now in order to find the base of a circular cone, we're given the formula B equals pi r squared. So this means that we're going to have to find the radius first, and we're going to put it into this formula, and that's how we would find out what our base is for the main formula. Now we're given that the height is 2r, so that means that would be plugged in right here for the height. So once we plug in everything that we've got, this is our new formula, which is V equals 2 over 3 pi r cubed. Now the volume of a sphere is a little more simpler than this right here. You don't have to find the base or the height or anything like that. All it is volume equals 4 over 3 times pi r squared. And then we've got the volume of a cylinder. And the volume of a cylinder is V equals base times height. And once again, like we did over here, we've got to find the base of the circular cylinder. And luckily, it's the same formula, which is V equals pi r squared. And once again, we're given our height from the problem, which is 2r. So when we plug in those things into our formula, our new formula will be V equals 2 pi r cubed. Now, in order to prove that these areas have a volume that is 1 to 2 to 3, the ratio, we've got to divide each of these formulas by the volume of our cone, which is 2 over 3 times pi r cubed. So when we divide this by this, when we always divide something by itself, it's always going to be 1. So you don't even have to do any math here. Your answer will always be 1. Now we're going to divide the volume of a sphere by the volume of our cone. And once we do that, we get 2. And we're going to do the same thing over here. We're going to divide the volume of our cylinder by the volume of our cone, and we get 3. So this shows you and proves that the ratio of the volumes of the cone to the sphere to the cylinder is a 1 to 2 to 3 ratio. So this one, it can be a little confusing, but once you know how to work it out and once you know your formulas, it's very, very simple. So we're moving on to question 5 now. And question 5 gives us this figure, and we are supposed to find the surface area of it. Now, the name of this is a right trapezoidal prism, and if you can tell, I see 2 different shapes within this figure. If you look, this up here is a rectangle, and this right here is a triangle. So this means that we can find the surface area of the rectangle and then find the surface area of the triangle and add them together to find our surface area. So, this also means that because this is 12 centimeters, this is also going to equal 12 centimeters. Now, the area of a rectangle is area equals length times width, and we're going to use that to find the area of this rectangle. So we're going to do our length, which is 17 centimeters, times our width, which is 12 centimeters, because this one is also 12. And when we multiply those together, we get 204 centimeters squared. Now, the area of a triangle is area equals 1/2 base times height. Now you might be wondering how we're going to find the base of the triangle, but it's super simple. We know that this whole side equals 26 centimeters, and over here, this side equals 17 centimeters. So we can just subtract 17 from 26, which gives us 9 centimeters. So this little part right here is going to be our base for the triangle. So we're going to multiply 1/2 times 9 for our base times 12 for our height. And when we do that, we get 54 centimeters squared. Now we're just going to add these two together, and we get 258 centimeters squared. Now that is the surface area of the bases, which is the top and the bottom down here. Now the next step is to find the perimeter. And in order to find the perimeter, we're going to just add all of our sides together. So this full side is 26 plus 12 plus 17 and then plus 15, and that equals 70. We did not add this 12 because that is inside of the figure and we're only looking for the measurements on the outside. And we didn't add the 4 because that is the height of the figure. It's not one of the lengths. But we are going to multiply our height by the perimeter, which is 70. So 70 times 4 equals 280 centimeters. Now I accidentally clicked ahead and y'all saw this down here, but we're going to add 280 because that's what we just found, and we're going to add 2 of the bases, the surface areas for the bases that we found, which is 258 centimeters squared, and we're adding 2 because there's a top and a bottom. So once you add these 3 numbers together, it will equal 796 centimeters squared. And for part B, we have another figure which looks like this, and we got to find the surface area of this as well. Now this one's going to look a little bit different. This is a triangular prism, and because it's a triangular prism, we can use this formula right here to find the surface area. So surface area equals 2 times the base plus perimeter times height. Now, in order to find the base of this right here, which is our base, we've got to use another formula, which will give us the base, and it's 1/2 times little base times height. So we're going to plug in our numbers. So this right here is our base of the actual base that we're trying to find. So 15. We're going to times it by 7 for our height. And when we do that, we get 52.5 meters squared. So that means that the surface area for the base is 52.5 meters squared. Now we've also got to find the perimeter since that's a part of our formula. And like we've been doing all throughout this video, the perimeter is the length of each side added together. So because this equals 15, we know that this equals 15. So 15 plus 8 plus 7 equals 40 meters. Now that we've found everything that we need for our surface area formula, we're going to just plug everything in. So that means that the surface area equals 2 times our big B, which is 52.5, plus our perimeter, which is 40, times our height, which is 7, and we can see that right here. Now once we multiply 2 times 52.5, we get 105, and then once we multiply 40 by 7, we get 280. We're going to add these 2 numbers, and now we get 385 meters squared for our surface area of this figure right here. So it's not too bad. Now last question, I know y'all are excited. This question wants us to also find the surface area, but this time we're going to find the volume too. So this is our first figure that we've got. Now I want you to notice that there is a cylinder right here, and we've got half of a sphere right here and another half of a sphere right here. So those 2 halves are going to equal 1 sphere. So that means that we can take the surface area of the cylinder and the surface area of the sphere and add them together to find the surface area of the whole figure. So this is our equation, our formula that we're going to use, and this is the surface area of the sphere, 2 pi RH, plus the surface area of the cylinder, which is 4 pi r squared. So we're going to plug in what we have here in our problem into this formula. Now the radius, once again, it's always going to be half of the diameter. Now the diameter is 8, so 8 divided by 2 equals 4. So that means that 4 will be our radius, and this is what it will look like when we plug it into the problem. So surface area equals 2 pi times 4, which is the radius, times 21, which is the height, plus 4 pi times the radius, which is 4 squared. And when we do that, we get 729 feet squared. Now the volume we've also got to find, and we can do the same thing. We can add the volume of the sphere with the volume of the cylinder, and this will be our formula when we do so. So we're going to plug in our radius and our height again into this formula. And when we do that, we get 4 over 3 times pi times 4 cubed plus pi times 4 squared times 21. And when we add and multiply that, we get our volume, which is 1,324 feet cubed. And notice that volume is always going to be cubed, while area is always going to be squared. So don't get those two confused. Now we've got one more part to this problem, and then we're done. This is our next figure, and we've also got to find the surface area and the volume for this. So we're going to use this formula right here so that we can find the surface area for this figure. Now, there is a new little letter, the S, that we've got to figure out what that means and solve for. So S just means the slant of the cone. So our slant is 6 meters. So every time we see that S, we're going to plug in a 6. Now, we've got our radius that we've got to find and our height, which is 10. So here we go. Our radius is actually given to us, which is 2 meters. So when we plug it in, we've got surface area equals pi times 2 squared plus pi times 2 times 6 plus 2 pi times 2 times 10. And when we do that, we get our surface area, which equals 176 meters squared. Now our volume, this is going to be the formula we're going to use for our volume. Now notice we've got an H1 and an H2. We already have our H1, which is 10, but now we've got to find our H2, which would be right here. We don't have that number, so we are going to use the Pythagorean theorem, and we're going to do the square root of 6 squared minus 2 squared. And once we do the Pythagorean theorem and enter this in, we get 5.7. So that means that H2 equals 5.7. Now we're going to just plug 5.7 into this equation. And once we do that, we get volume equals pi times 2 squared times 10 plus 1/3 times pi times 2 squared times 5.7. And that gives us our final answer of 150 meters cubed. And once again, notice that down here, volume is cubed while area is squared. So once again, don't get those mixed up or confused. It'll always be the same. Now that concludes our homework assignment. I know y'all are super excited because we are officially on spring break now, right? So I hope that y'all have fun and get a lot of sunshine for me. I'll see you guys in class in about a week. Thank y'all. Bye-bye.